Good morning, everybody. Hope you're doing well. Don't need these. All right. Ooh, I'm gonna do one thing real quick. Just stay right there. All right. Cool. Well, I'm here at school filming a little video for you. Uh, yeah, let's just jump into it. Save you some time here. You're gonna do this. You're gonna do some work out of the book, and I think that's all it is here. Ooh, okay. Sorry, Zoom updated some things, so. Interesting. All right. Sorry you're missing the questionnaires because I'm not there, but we're jumping into an important lesson, and I'm sorry about this that I'm not here, but I'm on Kairos. And I guess we're just planning on showing you some stuff. So here we go. So this is the part of the chapter where we are going to jump into measures of center, measures of spread. We did all our graphing stuff at the first part of this chapter, and we'll still do more graphing for sure. But now we're going to talk more about like measuring single variable distributions. And today we're talking about measures of center. Okay. So we've talked a little bit about this, but the idea of a median is that it is the middle of a distribution, like it's its physical center. Okay. Uh, like if you had 11 data points, right? Number six is going to be the median, whatever is exactly in the center of the data. And it's a good way to get the middle of the data. All right. It's a good way to get the middle of the data. Here's the actual definition for you. Median is the midpoint. Okay. Another way to think of it, it's the midpoint of the distribution. Half of the observations are smaller and about half are larger. We say about because if you have an even data set, then your median is exactly half and half. But if it's odd, no, the other way. Anyways, doesn't matter. Uh, about half are going to be smaller and half are going to be larger. So that's the median. Now, just a reminder with these videos, I'm going to just kind of keep going. So you should be pausing the video to write some of this down. Again, be a smart note taker. You don't have to write everything, but you should probably write like the definition of a median. That's probably a good thing to write down. And then we're going to do some examples on how to find the median, maybe do an example. Okay. I don't think this video is going to be super long, but yeah. All right. So finding the median. So step one, right? Again, I know we're kind of we get upset if our data doesn't look great. Um, like we get kind of messy data, it's not organized, but that's just a fact of life when you're getting data, right? Your data is going to be all over the place. Your data sets aren't always going to be nice. You got to clean or scrub your data if you're doing really large data sets. But for the median, the first thing you got to do is just put your data values in order, smallest to largest. And you'll kind of again be like, oh man, this is so silly to do this to find one thing. But next week we will just also need to put them in order to find another thing. So you might as well just do it. It'll help you get organized. It'll help you make a dot plot if you're going to make the data from it. So just get your data in order. It's going to make everything a lot easier. It takes a little bit of time sometime. I understand, but you're totally capable of doing it. Okay, so if you have an odd number of data, we use n as the number of data points. Okay, the variable n is kind of like you have n data points. We use that a lot in statistics. So if you have an odd set, an odd data value, the median is the exact middle. Okay, the median is the exact middle. What do we do if we have an even data set here, folks? What do we do if we have an even data set? Who do we got? Nick's answering a question? What? Nick? Yeah. Okay, Nick's right. If we have an even data set, okay, we take the average of the middle two numbers, okay? So if you have 10 things, you're going to take the average of the fifth and sixth data point, okay? So those are two good things you probably want to write down. Remember those. You will do it enough at this point that that shouldn't be too much of an issue. But let's do an example. Ooh, we got two. One's even, one's odd. I love it. Okay, here we go. So we got to put these in order first. So we got 21. We got what's next? 24. You don't really need the commas even. Let's get rid of them. 25. 32. Nope, 27. Ooh, almost missed that one. Careful out there, kids. See, and again, good, if you're doing this at home, good idea to just cancel. 32. This thing will go away. Go away. Oh, there it goes. Okay. Let's get rid of this. 32, 34, 37. Okay, so put them in order. 1, 2, 3, 4, 5, 6, 7. So it's odd. So it's just going to be the exact middle. So what I like to put like little brackets around it. Again, we're going to do this later. Next week, I'm going to come back with a vengeance, kids. And we're going to do this next week. And we're going to want to isolate that middle number. Okay. So just a good habit to get into here, but our median here. Woo-wee. Sometimes it's been a while since I made one of these videos and my writing is tough. Just with the old mousearoo, kids. So still pretty good. Median is 27. Boom. That's all you got to do. Okay, let's look at this one. So we got 4, putting them in order. 8, doop, 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 12, 16, 17, 21. Okay, this is an even data set. 6. Okay, so now, again, I would get in the habit of draw those brackets just to be clear, like, hey, the median is here because it's an even data set. And so it's in between these. Okay, so what is this, 14? So your median is here. This will help you a ton in the future if you just get into good habits. All right, median is 14. And again, I know this is like, you're like, okay, I did this in 5th grade. This is super easy. But we got to make sure everyone's on the same page here, especially with me. And we'll quickly get to some more challenging stuff. Okay? Next week, we're going to jump into standard deviation. Okay? Nice. All right, so here's another one. You could do this on your own. So if you want to pause and put another example in there, find the median, ooh, and interpret this value in this context. You're going to hear that a lot over the next however long. Interpret this value in the context. So we might say the median of grams of fat in McDonald's sandwiches is whatever you find, okay? So if you want another example, you can pause, do that here. But basically, that's the median. It's the middle. It's the middle. All right, so we're moving on to the old mean-aroo. And the mean is just the average. So you take all the data, all the n data points, you add them together, you divide by n, okay? So we will see this too. It's just the average, but you might see it written as like mean, right? So you might say mean equals something. Or we're going to really see this a lot in the future. We're going to see the mean as X bar. Okay, X bar is going to stand for mean. You just write an X with a little bar on it. And then probably second semester, we're going to see mean more as mu. It's this weird little Greek letter. It's like a bigger U. but we'll see mean written like that as well. So you might see all three of these. I think this chapter would more like X bar territory, and then later chapters would kind of get into the old mu game. So just keep an eye out for those, and I'll re-explain them as we see them come along, huh? Oh, I left a lot of space there to write all that, and I've scrunched it in. So bait, really simple. We add all the values up and divide by n. Okay. Oop, we didn't want to go that far. Okay. We got it. So what we're going to do is we're going to do 2 plus 5 plus 7 plus 8 plus 9 plus 10 plus 15. Okay, and then you're going to divide by n. Remember, n stands for the number of data points in the data set. Okay, in this data set, what do we got? 1, 2, 3, 4, 5, 6, 7. So we're going to divide by 7. We're just finding the average, folks. Just finding the average. See if you can do this on your own. You guys got a calculator out there? I'll do it too. I'll do it too. So you should get 56 is what I got. Check me, make sure I got the right thing. So we're going to go 56 divided by 7. And we get 8. We get 8. So that's your mean. So again, you could say X bar equals 8. You could say mean equals 8. You could say mu2 equals 8. Any of that works. All right. Little Sunday morning right before the old football starts. All good. Hope you're having a great weekend. Although now you're looking at this on Wednesday or Thursday. See what else we got down here. Ooh, this is good. This is good stuff here, folks. A measure of center, that's what we're talking about today, are measures of center. Next week, we'll talk about measures of spread. But a measure of center is resistant. That's a word for you. If it isn't influenced by unusually large or unusually small values. Okay. So that probably means this is what it's trying to say here, and you could rewrite this. Outliers, right? So a measure of center is resistant if it's not influenced by outliers. Super important. Super duper important. And we have talked about this in class before. But the mean is not resistant. The mean is influenced by small and large outliers, okay? The median is resistant, okay? And maybe we should have fully written that out. The median is resistant. So we talked about this in class earlier, but a really good example is home price values, okay? You're on the market, you're looking for a house, okay? You're a little bit away from that, but maybe Mr. T's closer. You don't want to look at average home prices or mean home prices. You don't want to look at that. Okay, because it's going to be skewed. It's going to be skewed. Usually home prices are skewed by on the higher end. Okay. You're not going to really find much in Seattle house-wise for under 500,000. If you do, there's probably an issue with it. But you're going to find some that are really expensive, right? You're going to find something on the water that's gigantic or whatever, and it's got a view or something, and it's going to be, 3, 4, 5 million. Those big outlier ones are going to skew the mean. And so your mean home prices in Seattle are going to be a lot more expensive because of those outliers. So anytime you see housing prices and you're looking at to buy a home, you always see median. You always see median no matter where you are. Seattle is not the only one that does that because median is just a lot more accurate. Okay. We're finding kind of the middle home price in Seattle. So that would be something on the large end. Can we think of an example on the small end? I don't know. What would be a good example on the small end? Um, I don't know, like maybe you have some zeros and some data, like one of you guys kept asking questions when we did like get up, move around, ask questions of like how many pets do you have? Most people had a pet. Mr. T had zero, and I probably skewed the mean with a zero. Like most of you all had, two or three pets, and I had a zero. So that probably could skew something like that. Zeros could skew it if it's something, but you could have other small values. I don't know. You can think of an example. All right. So this one was another example, lacrosse, or sorry, basketball, baseball. God, I can't even read. Baseball games, how many runs they scored. So these are already nicely in order for you, but we're not finding the median, we're finding the mean. So you could add these all up, find the mean. These could maybe be influencing. These larger ones could be influencing possibly, right? We'd say skewed right. Well, the mean also gets skewed to the right too. Okay. So our mean gets skewed to the right by these higher numbers. Oh, don't do that. Stupid Zoom. All right, let's get to our last little talking point here, and then you got some homework out of the Libro. So, which measure of center should we use? Okay. Should we use the mean or the median? We already discussed a little bit about resistance. So, which one should we use? Some of you are probably just like, well, we should always use the median because it's not going to be skewed by outliers, man. And that makes a lot of sense. The issue with the median is it gets a little harder with bigger data sets, unless you're using like some coding or programming software. If you're doing stuff by hand, like we are in our class, mean can be a lot easier. Calculators like to find the mean easier. So that's all stuff like that. But here's the thing in general. It depends on the shape of the distribution and outliers, okay? So it depends on those two things. Here's a little good visual for you of how the mean gets skewed, okay? So look at our distribution on this one on the left. Clearly, our data is skewed to the left. Okay. The mean is 17.97. Okay. But the median, sorry, I kind of put my thing in front of it, but the median is 19. Okay. So do you see how these can be pretty different? Okay. Our mean is a little bit under 18 and our median is 19. Right? So the mean gets pulled in the direction of the skewness. Look at the one on the right, same thing. Okay. We're skewed to the right this time. Our mean gets higher here. Our mean is 4.14, but our median is 3. So the mean moves in the direction of the skewness. See how this is all starting to come together and why it's like, oh, this is easy, but it's cool, right? If you look at something that's roughly symmetric, this isn't perfectly symmetric, but it's roughly symmetric. You get your median is 15.8 and you get your mean is 15.78. Fascinating stuff here, right? It makes a lot of sense, but it's also like when you see it like this, it's pretty cool. So here's kind of our basic idea. Okay. If a distribution is roughly symmetric or perfectly symmetric, okay, roughly or perfectly symmetric, and has no outliers, okay, no outliers, use the mean. Okay. The mean is just going to be easier to find a lot of the time. It's going to be easier to calculate. Your calculator is going to do it. When we do other things, it's going to be easier to get the mean. Okay. In a technology-based world, mean is easy. But if we do have a distribution that's strongly skewed or has outliers, we want to use the median. Okay, because we can't really trust that mean. It's going to get pulled and skewed and whatever. Okay, I have one more example. I don't know if how long this video is. Maybe it's too long. Maybe I'll save it for in person. I got a really good example of mean versus median. Maybe we will start that when I come back. before we talk about spread, we'll talk about this really good example of mean versus median. But I think that's it. I was going to have you do a little in-class assignment, but I think, you're going to do some problems out of the book, and I would like you to do those now. So don't like start doing some other homework. You probably have plenty of time right now. So please do those first so your sub feels like you accomplished them. And then once you're done with those, you can work on something for another class. So go on Google Classroom, take a look at what the problems are, and do them. Thanks for watching. Hope you have a great day, and I'll see you soon. All right.